Hi, we are FiberFox, Hawes, Collier, Evan Murphy, Kyrsten, Rudock, and Rebecca Smith. We are from Haley Queen's E101 class 04 honors, and we are going to tell you about our engineering design process of our fabric bucket.
The minimum requirements for the fabric bucket was to create a bucket out of fabric that could hold a gallon of water for 1 minute without leaking. However, the way to get the most points was to hold the most weight in water per gram of fabric. We could also meet some other requirements for a bonus multiplier. These multipliers included things like having 3 different types of fabric, turning the fabric bucket into a backpack, and/or making the bucket biodegradable.
It was not difficult to ask questions for this project because the premise is so odd. A fabric bucket, what is that supposed to be? We first had to ask ourselves what shape we had to make it into in order for it to hold water. Then we had to determine what fabric to use and how to make it waterproof. Another important question was how we could procure the materials and resources we needed. With some research into polymers, we found that synthetic fabrics like nylon and polyester were the best at preventing water from passing through it. Essential to our final design, we found that Kevlar was incredibly tough and waterproof. With some research, we found a commercial brand of waterproofing agent called Never Wet. However, later we discovered a much more potent and durable waterproofing agent.
With 2 textile engineers on the team, we were able to combine ideas from our Textiles 101 class. We thought about using braids and wovens from the start because we were told they are some of the strongest textiles. We initially wanted our bucket to be marketable to the public, so we imagined using tools that are popular in the textiles industry. For instance, non-wovens are the most affordable fabric on the market, but we soon realized we could not use them for our entire project because they are not strong enough. We wanted to make a filter because we learned how textiles can be used for filters due to their pore size. We used ideas from hydrostatic force and pressure problems for the base. In the end, not many of our ideas made it into the final product. Through trial and error, we discovered what was practical.
We started our plan by gathering materials. Our 2 textiles engineers were able to talk to some professors and get 2 types of fabrics, both of which we used in our bucket. In addition, our team took a trip over to a local fabric store to pick out another fabric, a braided rope, and a spool of thread. Once we had all of our materials, we drew a diagram and then went over to the craft center and learned how to use the sewing machines.
Next in the design cycle, we took the dimensions of the initial bucket and started to fabricate our bucket. We made our bucket with the materials gathered from the College of Textiles and created it by using the sewing machines available at the Craft Center. While at the Craft Center, we received a lot of guidance from Miss Westmoreland about what sewing techniques to use. While trying to figure out the best waterproofing agent, we decided to create our own. To make the agent, we took a trip to the College of Textiles to work with Dr. Jeff Krause. While in his laboratory, we used his chemical resources to make a waterproofing chemical bath for our bucket to be coated with. First, we had to measure out the correct masses of the waterproofing agents and then soaked the bucket in the mixture we made. From there, we proceeded to centrifuge the bucket and then dry it. The final step was to cure the bucket in an oven. This ensured that the waterproofing agent did not merely wash off after testing. When we first started to design our bucket, we made it tall and narrow. The base was made from Kevlar and the sides were polyester. After testing, we realized that the polyester was not water resistant enough and decided to make our second prototype entirely out of Kevlar. We also redesigned it so that it was shorter and had a wider base, so that the pressure of the water was distributed more evenly. The second prototype worked a lot better, but there were still a few leaks at the seams, so we decided to make a third. For the third bucket, we added a double-layered bottom so that if there were leaks at the seams, it would have to go through another layer of fabric. We also bought fray check that would act as a seam sealant and keep the Kevlar from fraying.
We obtained first place in the Fed afternoon session with a score of 31 points. Our bucket was one of the lightest buckets there, with a mass of 173 grams. Our bucket successfully held the required 1 gallon of water without leaking for the first minute, the initial goal of the fabric bucket, but then went on to hold a total of 5.5 kilograms before it started to leak.
Our first challenge was simply time because we all had different schedules and extracurriculars. We could meet at night to plan, but we found that actually making the bucket together was difficult because of our schedules and the hours of the craft center and textile professors who helped us. Sewing the bucket was also very time-consuming. Once we made a plan, it took until we finished each prototype to see what was wrong with it. This made improving the design difficult because it was not time efficient. Another challenge we faced was that none of us had sewing experience, and especially not with Kevlar, which is hard even for experienced sewers. It took us a while to get used to the sewing equipment and learn how to use it properly. While we had challenges planning the bucket's design, there was also the daunting question of how we would even complete our goal. We could not find a waterproofing agent that met our needs. Finally, we decided to make one on our own. We had to speak to 3 different people and explore the textile labs over the course of several weeks before we landed in a lab that allowed us to finally make our successful waterproofing agent.
Some advice we would give to freshmen is to start the project early. Since we started making prototypes of the fabric bucket early, we were able to see what worked and what didn't. This allowed us to make and test several prototypes well before Fed. We would also advise freshmen to take advantage of the resources on campus, like professors and the Craft Center. We took the initiative to get in contact with professors at the College of Textiles and use some of their resources to make our fabric bucket. The Craft Center was also very useful because they had a lot of sewing supplies we needed at no charge.
Even though we won first place at the fabric bucket competition, there was a lot we could have done better. If we sought out help from the textiles department earlier, we could have easily made a much larger and lighter bucket that could have scored at least double the points in competition. Taking more initiative and seeking professional advice earlier is something we definitely should have done. Overall, thanks to a great cohesive team, we pulled out a victory.